This is group 2 and we are presenting on IO. IO. Now, IO basically stands for input output. Yes. So this is the group members of the group. We are 10 actually number, and I'm the group leader of the group. So now let's get to know what an IO is. I/O is the communication between an information processing system and the outside world. Yes, for you to be able to communicate with your information processing system, you need I/O, which enables you with certain protocols and functionalities for you to be able to communicate or interact with your system. Yes. So let's see the importance of I/O. I/O enables interaction. Now, I/O systems enables us to interact with various systems and devices. Now, for you to be able to send or receive information or interact with your device, you need the I/O. Yes, some of these I/O devices which help you to interact with your device is the mouse, the keyboard, and joysticks and other stuffs. So they help you to input data into the computer and output data out of your computer or your I/O system. Now, I/O systems facilitate data exchange. I I/O I/O help us to transmit data from one location to the other. Now, we have some types of I/O devices like the networking and the storage devices. So we can actually store data on these I/O devices and then transmit them to different locations using your network I/O devices. So now I/O impacts functionality. So I/O impacts functionality of devices when I/O devices are used to send commands to the device. So now some of these devices are the joysticks. For example, you use it to send information to the computer to put in certain functionalities into your video game. Yes, so you can use it to impact functionalities of your computer, not only the video games but to also issue commands to your computer. So you can use the keyboard also to issue certain commands to the computer, which actually helps it to perform certain functions, hence impacting its functionalities. So I'll leave it here for the next person to present.
Okay, I'll be talking about the types of input and output devices. Okay, input devices. Input devices are devices that send data or control signals to the computer system. They allow users to interact and provide information to the computer. Output devices. They are devices that take process data from the CPU and present it in a form that is understandable to the user. Storage devices. They are devices that either temporarily or permanently hold information. They can be either internal or external to the computer system. Network devices. They are devices that are used to communicate between the computer and other devices over a network. Thank you.
So also the parallel input output data transfer mode. So parallel input output mode it refers to the simultaneous transmission of multiple bits of data over multiple communication channels or wires. The data transfer rate is faster than a serial input output since multiple bits are sent at the same time. and also they are commonly used in the parallel port internal computer buses like the PCI and ATE. So advantages is faster data transfer rate. That is it allows multiple bits to be sent simultaneously and has higher bandwidth. That is more data can be transferred in a given time period. Thank you.
Okay. So now you have the program IO. A program, okay, so what you mean by a program IO is a method of data transmission via input and output between central processing unit, that's the CPU, and a peripheral device, such as parallel ATA and storage device. So you talk about the the IOS. So the IO. So one, the CPU controls IO directly. So what you mean by that? Is the CPU control IO devices directly using various methods, as you can see on the screen. So the second one is one method for the CPU to directly manage data transfer between itself and the IO devices using instruction. Okay, so the third one is IO method. So that another method is IO devices are mapped to memory addresses, allowing the CPU to access them like regular memory. Okay, so lastly, you have devices are accessed through specific ports, and the CPU uses specific instruction to communicate with them. That's um so that's the fundamental of the IO. It's used to it's a method that is used to transmit data via input or output peripheral devices.
My name is Pearl Denso, and I'm here to talk about interrupt driven IO. So, I'm going to give an overview of what interrupt driven IO is. Interrupt driven IO, where IO stands for input output, is a technique where an IO device sends a signal to the CPU when it needs attention or has completed a task. This allows for the CPU to focus on other tasks. The CPU can execute other instructions while waiting for the I/O operations to complete. This also makes the CPU respond promptly. Thus, when an interrupt occurs, the CPU can quickly attend to the I/O device's needs. Now let's talk about the process. I/O devices, first of all, I/O devices generate interrupts. The device sends a signal to the CPU. Then the CPU saves current state. The yes, it saves its current content. Sorry. CPU executes. Let me take the second process again. The CPU saves the current state as it saves its current content. Then the third step is that the CPU executes interrupt handler. Interrupt handler is being executed to handle the interrupt. Then the fourth process is that the I/O operation is performed. The CPU attends to the I/O device's needs. Then lastly, the CPU resumes its previous task. After handling the interrupts, the CPU returns to its previous task. Thank you.
So we're talking about the direct memory access. Yeah, direct memory access is a technique that allows input-output devices to transfer data directly to or from system memory without involving a CPU. So with this technique, the CPU is not involved, and since the CPU is not involved, the DMA can transfer data at higher speed, and also it increases the CPU efficiency since the CPU is free to perform other tasks while the DMA handles the data transfer. Also, since the CPU is not involved, it reduces the CPU utilization by offloading data transfer tasks. The DMA reduces the CPU's workload. DMA is commonly used in the disk I/O, that is transfers data between the storage system and system memory, storage devices and system memory, and also the network I/O for transferring data between network interface and system memory, and also the graphic processing that transfer graphics data between devices and system memory. So the process involved in disk memory, direct memory access. So the process
the input output requests the DMA transfer. So the input output sends a request to the DMA controller. The DMA controller manages the transfer, it handles the transfer between the input output device and the system memory. And the CPU can continue its execution. Once again, since the CPU is not involved, the CPU can execute other instructions while the DMA transfer takes.
Alright, so my name is Innocent, and I'm taking techniques and types comparison. So on our screen here, you can see the technique, the CPU involvement, the efficiency, and the speed. Right. So under the technique, we have program input and output, which its CPU involvement is high, and then efficiency is low, and then the speed is also slow. And then move on to the interrupt driven input and output, which its CPU involvement is medium. The efficiency is also medium, and the speed is also medium. And then also we move on to the DMA. With the DMA, the CPU involvement is low, and then its efficiency is high, and the speed is very fast. And then move on to serial input and output, and then parallel input and output. Okay, so that's the type that I mentioned right now. That on my screen here, you have the type, and then you have the data transfer, you have the speed, and then the distance and the bandwidth. So serial input and output, um, the data transfer is one bit at a time, and then the speed is slow. The speed is slower, and then the distance is larger. And then the bandwidth is also smaller. And then move on to the parallel input and output, which um, the data transfer is multiple bits simultaneously, and the speed is faster, and then the distance is shorter, it's a shorter distance, and then the bandwidth is larger. Thank you.
Okay, so with this part, we'll be learning the common input and output interfaces, which we have the USB, which we know as the Universal Serial Bus. It's a super versatile interface, mostly used for connecting peripherals like the keyboard, mouse, storage device, and printers. Also, the USB has different versions like the USB 2.0, USB 3.0, and the newer version, which is the USB-C, which is reversible and can be faster. And we have the HDMI, the high definition multimedia interface. And with the HDMI, it is mostly used for transmitting high definition audios and videos from devices like computers, gaming consoles, Blu-ray players to displays like television, monitors, and projectors. And we have the Ethernet, which is mostly used for wired network connection, providing a stable and offer faster internet connection compared to Wi-Fi. It is commonly used in homes, offices, and data centers. And we have the Bluetooth, which is the wireless technology that allows us to connect devices like headphones, speakers, keyboard to our computer or phone without cables. It is convenient for the PAN, personal area network, as well. And we have the audio jacks. The audio jacks, they are classic ports for plugging in headphones or microphones. And with them, they are straightforward and widely used for video inputs and outputs. Yeah, so that's all.
Sanaholu Bedu. And today
I'll be talking about iOS system challenges. So I'm about to mention some challenges in iOS system. Okay, one, speed mismatch. iOS devices often operate at different speed than the CPU or memory, causing bottleneck. Two, data transfer overhead. Moving data between devices can be time consuming and resource intensive. Three, device compatibility. This means different devices may have varying interface protocol and requirements, making integration challenging. Then another step is scalability. iOS system needs to be scalable to accommodate increasing demand and new devices. And again, the next one is security. Okay, so here iOS system faces issue in ensuring the security and integrity of data transfer between devices. Okay, and another one is buffer management. So here the buffer management, managing data buffer to prevent overflow or overflows can be tricky. The last one is error handling. Here, detecting and handling errors such as device failure or corruption is crucial. So I'll be leaving this one to another person to present on.
Okay, we have come to the conclusion or the ending part of our presentation. Yes, so at the end of our presentation, we were able to cover 10 topics. Yes, so from the beginning, we were able to talk about what I/O is and its importance, talk about types of I/O devices, we talk about data transfer modes in I/O devices, and talked about programmed I/O, interrupt-driven I/O, and direct memory access, which the three are techniques in which I/O devices use in transmitting data, and then the comparison between the types and then the techniques. So the IO techniques and types comparison to show the similarities or differences in them. Then the common IO interfaces, and then the system challenges, and then the evolution of IO systems. So beside it is the various people who actually presented on the various topics. So this brings us to the end of our presentation.
Mm. The evolution of IO standards. IO standards evolved from the early days to the standardization days, serial interfaces, high-speed interfaces, wireless interfaces, and modern trends. At first, every computer had a different shaped doorway, which are the ports, where you fit in different cables to connect it to a different device. Then later, everyone agreed that there should be few shaped doorways, like the old printer ports. That was a lot better because a different device from any company would fit. Then during the serial interface stage, we invented much faster doorways like the USB ports, you see all the time. After that, for really big heavy duty jobs, we created super fast doorways that could handle huge amounts of data being transferred. Then finally, during the modern standards, we got rid of all the doorways altogether and we learned how to send information via wireless Wi-Fi signals or Bluetooth. Thank you. Okay, the next part is the key drivers, which are technological advancements. Um, because technology kept evolving, we started because we started getting smarter, we started to invent new things which made technology evolve and better. The second part is the increasing demand of speed and bandwidth. People want things faster. We get impatient waiting for big files to load or transfers. That's why the I/O standards evolve to the day to where it is now. And the next part is need for interoperability. We everything needs to work together. We don't have to worry if a new mouse will work with our computer. We just want to plug it in and have it work. Because of the different doorways, you can't you during the early days, you wouldn't be sure whether this mouse will work for a different computer or not. Because of that, we have to make all of them work on the same we have to make all of them the same piece, like it has to connect to the same device or different devices. And the second, security and reliability concerns. We need to make our data secure and our connections so that they don't suddenly stop working. That keeps things safe and dependable. Thank you.